Welcome to the next session of Learn Scratch Programming. Let's learn how to create new sprites. Open Scratch. Right-click on the cat sprite below the stage and click Delete. Now the cat sprite is gone. Click Choose a Sprite button next to the bottom right corner. A few options will pop up. Move the mouse over the options and click on the Paint option. This will open the Costumes tab with the Paint window editor. You can create a new sprite here, using the Paint tools. This is similar to using the Paint software. To use a tool, select the tool by clicking it, and then drag it using the mouse. Let's draw a human figure facing front. Using the Circle tool, and draw a circle on the drawing area as shown here. Select the circle, and drag it to the center point of the drawing area. Click the Fill menu, to change the fill color of the shape drawn. Click the Outline menu, to change the color of the outline of the shape drawn. The thickness of the outline can also be changed by editing the number next to it. Complete the sprite as shown here. Set the center of the sprite as you require. The crosshair within the drawing can be used as a guiding point to set the center of the sprite. The crosshair on the grid is the actual center point of the grid. The center of the drawing can be aligned relative to this grid center. Aligning the center point is critical if animations and artwork are to be done by turning or rotating the sprite. Offsetting the center of the sprite from the grid center can be used to create varieties of artworks. We shall see that later. In this example, we align the grid center with the sprite center. Select the entire drawing using the Select tool. Drag the drawing and align it with the grid center. Give the sprite a name. Here we give it as Dancer. Your sprite is ready now. New sprites can be chosen from the library also. There are several categories available. You may choose any. A sample is shown here. You can also edit the sprite using the sprite editor tool as we saw earlier. The surprise option randomly selects a sprite from the library and inserts it in the project. The upload sprite option allows your drawing, or a picture chosen by you, to be used as a sprite. To animate the sprite, we require costumes. Next we create costumes for our sprite. So, what are costumes? The sprite could have a different color, different size, different angle of view, or even different shape in an animation. You might have seen this in TV cartoons. How does the Mickey Mouse move on the screen? How does Tom and Jerry work? Each movement of the character has to be a costume. Only then the animation can be done. Let's emulate that by animating the dancer sprite by creating more costumes. The animations will be smooth and flawless only if more costumes are there, depicting each movement or change. This is very time consuming and requires patience. In our example, we will be creating only 4 costumes. Click on the dancer sprite. Open the costumes tab. Change the name of the current costume to front. Right-click on the front costume and click Duplicate. Create a total of 4 costumes. Name the new 3 costumes as left, back and right respectively. Use the paint tools and edit each costume to look like as if they are facing front, facing right, facing back and facing left. So now we have 4 costumes. Each costume is a different pose of the same dancer sprite. How to change the costumes? The switch costume block can be used for that. On clicking the down arrow, all the costumes available for the sprite will be listed. You can choose which costume to switch to. Alternatively, you may use the next costume block to change the costume. This command block selects the next costume in order. In our case, there are 4 costumes. The costumes are arranged in an order and they have a positional number. So each time the next costume block is invoked, the next costume in incrementing order is displayed. After the final costume, it loops back to the first costume again. Now let's animate the sprite by changing the costumes. In this exercise, we use the next costume block. Let's make the human figure dance. Connect the blocks as shown here. The forever block from control palette is used to repeat the activity within it, forever. Here we want the dance to run forever. So we put the next costume command block from look section within the forever block. So each time the loop repeats, the next costume in order is chosen to be displayed. This happens forever. That is, first front, then left, after that back, then right, then again front, and so on. On clicking the green flag, it runs very fast, that we can barely see the dance moves. This is because the loop is running at high speed. So we need to pause after each move. Connect wait seconds block also from control palette to the script. Click the green flag. We can see that 1 second is too slow. Let's make it 0.5 seconds. Run again to see the sprite rotating faster. Now let's try the costume change using switch costume to block. You can specifically choose which costume to change to with this command block. In the previous example, the costumes changed in incrementing order. We can deliberately change the order with this command block. Let's try a different dance move. In the first method, the order was fixed and in ascending mode. In the second method, you could specifically choose which costume to change to. Next, we use a method to choose random costume. There will be no specific order. From the operators palette, choose the pick random block. You could see that this block has rounded edges. The pick random block used here returns a random number from 1 to 4. We used 1 to 4 because we have only 4 costumes. This block will be used as input to switch costume to block. Depending on the number returned, the costume ID that matches the number will be displayed. Let's create a new background for our animation. Just like we discussed the creation of new sprites, new backgrounds can also be created. Select the stage and click on Choose a Backdrop option. This option allows us to choose the required background from the library. The paint editor you see here is same as what we saw when editing costumes. The only difference is that we are creating a background and not costumes or sprites. The surprise in upload backdrop option also works similar to what we saw with sprites. The surprise option selects a backdrop from the library randomly, whereas the upload backdrop option allows us to use an external image as backdrop. Now let's see how to switch the backdrops. The switch backdrop to block can be used to switch the background of the stage. On clicking the down arrow, all the backdrops used in the project will be listed. You can choose which backdrop to switch to. In addition to that, there are 3 more options. Next backdrop, previous backdrop, and random backdrop. The next backdrop switches the backdrop in ascending order. The previous backdrop switches the backdrop in descending order. The random backdrop selects a backdrop randomly from the list. These options were not there for costume selection. Alternatively, you may use the next backdrop block also for changing the backdrop. This command block selects the next backdrop in ascending order. This is similar to what we saw in costume selection. Now let's add backdrop animation to the dancer example. Here we are running the script to change the backdrop in backdrop script area. Connect the blocks as shown. At the same time, the script for sprite animation is running in the sprite script area. Both the scripts will run in parallel. The script for backdrop change could be run in the script area of stage also. Let's play music in Scratch. Our idea here is to play music while the dancer sprite dances. Go to Sounds tab and click on Choose a Sound button at the bottom left corner. Click on the Search option. This opens up the library. You will see a big list of different sound files in various categories. You can choose any. Select the Loops category and select Dance Magic file. We can include more than one sound file. Select guitar chords also from loops. The chosen files will be listed in the Sounds tab. Use the play button to play the sound. There are several options in this window here to edit the sound files. Just like the Paint editor is used to edit images, Sound editor can be used to edit sounds. Now let's see how we could use the selected sound files in our Dancer Sprite project. The Play Sound Until Done block from Sound Palette plays the selected audio file completely and only then moves on to the next command. Click the down arrow and select the sound file to be played, which is Dance Magic. But we need the music and the dance to play at the same time. So it's required to run a separate script for playing sound. That would run the sound script and dancer script in parallel. So we select Forever and When Green Flag Clicked blocks from the control palette. Connect them as shown. Now on clicking the green flag, the sprite dances forever, and the music also plays forever. The point to be learnt is that the play sound until done command should always be run in separate parallel script. Let's upgrade the dancer sprite example. Let's create a party mood for this project. Currently there is only one sprite on the stage. Let's make it 3 sprites and make all 3 of them do these activities together. It will be a nice dance show. Duplicate the sprite as shown. Make 2 more copies. Click on each sprite at the bottom and bring down the sizes of the sprite to 70, 70 and 70. Also rearrange the sprites. When we duplicate the sprite, script of the sprite also gets duplicated. So all the 3 sprites will have the same script. The script requires a correction. We have to delete the script to play sound from the 2 new sprites. Otherwise, when all 3 sprites play music together, it will sound bad. Do as shown. Now the script to play music is present only in one of the sprites. So we have 3 sprites with the dance program. One sprite has music script too. It's like a real show, where there will be multiple dancers on the stage and one music system playing the music. You may even add a new backdrop to spice up the stage. Click the green flag and enjoy the show. Next, let's see a robo dance animation. The script to make this can be downloaded from the site. Let's see how to make the sprite appear to say something, or to be thinking something. The Say and Think block creates a call-out shape, or a speech bubble, with the text inside. Basically it is a text box that looks like call-out shapes in comic books. When Say and Think block are used, the text gets displayed in a call-out shape, and it remains there, until another Say, or Think block usage, or until the Stop Script button is pressed. There is another set of command blocks for Say and Think. In this case the speech bubble disappears after the specified amount of time. Let's create a comic tale using what we learnt until now. The story is as follows. Ripley goes on a space mission to a distant planet on her spaceship. She finds that there is no life on the planet. She returns in her spaceship. On her way back she falls through a black hole, and emerges out of the other end of the wormhole, to a space city built by aliens. After the last backdrop the story ends. The backdrops used are from Scratch library itself. The script is shown here. We have used the when backdrop switches to block from the events palette in this application. This is used as a trigger. This is used to check if the last backdrop has been displayed. That means we can stop the script. For that we use stop all block from control palette. Try this application and make a better version of the story with more events. The XY grid. The stage where the sprite moves is like a grid. Each position on the grid has an address, just like each square on a chessboard. So if you want to move the sprite to a specific address on this XY grid, you have to pass the address to certain motion commands. So first let's learn about this grid addresses. In a chessboard there are 8 squares in a row and 8 squares in a column. So that means 8 steps wide and 8 steps long. Each square has an address. An example is shown here. Similarly, the stage is a bigger chessboard. It is 480 steps wide and 360 steps tall. The center position of the grid is the origin. Let's denote the horizontal position by X and vertical position by Y. A grid location can be denoted as X, Y. This is known as coordinate. The XY coordinate can denote the address of any location on the grid. So the origin becomes 0, 0. The rightmost position on the horizontal center line is 240, 0, and the leftmost position is minus 240, 0. Similarly, the topmost position on the vertical center line is 0, 180, and the bottom position is 0, minus 180. The current XY coordinate of the selected sprite on the stage is shown next to the sprite info area on the editor. If you drag the sprite to a different location, you will notice that this XY coordinate value will also be updated. Motion commands. There are two kinds of motion commands in Scratch. In method 1 you can directly specify the address to go to. For example, when the teacher says go to your classroom, it's an absolute command. No matter what your current position is, your final destination is the classroom. You know it, and you have to go there. In method 2, the directions are specified to reach the destination. For example, take a right turn, move 10 steps forward, and turn left for your classroom. Here the address is not specified, but the path to reach the destination is specified. We shall learn both these methods in this chapter. Let's see method 1 first. The go to XY block moves the sprite to the specified XY coordinates on the grid. When this command block is used, at the very next instant the sprite reaches the specified coordinate. Similarly, the glide to XY block also moves the sprite to the specified XY coordinate. But by gliding the sprite to the location for the specified duration. In the motion palette, there are 3 blocks that holds the current X position, Y position, and direction of sprite. On enabling them, these values will be displayed on the stage. The direction of the sprite can be changed by point in direction block. The sprite moves in the direction chosen from the current position. In method 2, the move steps block moves the sprite for the specified number of steps. The action is instant. We already learned this. The turn clockwise block turns the sprite in clockwise direction for the specified amount of degrees from the current direction. The turn counterclockwise block turns the sprite in counterclockwise direction for the specified amount of degrees from the current direction. There are a few special commands in the motion block. Let's check them one by one. The go to random position block can be used to move the sprite to a random position on the stage. The action is instant. This block is very useful when creating games. Try the script shown here and see how the sprite reacts. The go to mouse pointer block can be used to make the sprite follow the mouse pointer on stage. Try the following script and see how the sprite reacts. Add one more sprite ball using choose a sprite option. And then try the following scripts and see how it performs. Move the ball sprite using mouse. The cat sprite tries to follow the ball sprite. The glide to random position block is same as go to random position block. Except that here, the motion is smooth. The sprite glides to a random position. Try the script. The glide to mouse pointer block is same as go to mouse pointer block. Except that here, the motion is smooth. The sprite glides towards mouse pointer. Try the script shown here. The point towards block can be used to point the sprite towards mouse pointer or other sprites. To point towards another sprite, select the sprite's name. This block changes direction only. Try the script shown here. The if on edge bounce block causes the sprite to bounce off the stage edges. This is a very much needed block, especially in games. Sometimes the sprite may walk off the stage if unchecked. This block helps prevent that, and also it could be used to create a bouncing effect for sprites. Try the script shown here. Now let's try a simple application. Let's make a snake follow the mouse. We have two sprites here, a mouse sprite and a snake sprite. Insert them from the library. Add the following script to snake sprite. Now add the following script to the mouse sprite. Run the script and see the working. Have you heard about metamorphosis? Metamorphosis is the process by which a caterpillar changes to butterfly. It is the evolution of a butterfly. The butterfly lays eggs. Larvae comes out of it, which is the caterpillar. It eats leaves and turns into pupa. Finally, butterfly comes out of it. An animation demonstrating the process is shown here. The script is available for download. It's time to learn how to draw in Scratch. The pen commands can be used to draw on the stage. In fact, if we combine the pen commands with the motion commands, then we can create pictures on the stage. In Scratch 3, pen commands are available in the extension set. So select the pen extension. Every sprite has this pen tool attached to it. But its effect becomes visible only when the pen down command block is used. If the pen down command is used, and the sprite is moved, then the sprite will trace the path on the stage. By default, pen up is always enabled for the pen tool. If it is pen up, then the sprite path will not be traced. Try this example, and see the results. The Erase All command block erases the stage completely. Try the following command set. You can also change the color of the pen using the Set Pen Color command block. Let's draw a few squares using this tool. Try the script shown here. Now let's draw a helicopter. We use the blocks from Pen Palette, Motion Palette and Control Palette to make this drawing. Try the script shown here. In the previous session, we used the pen tool to draw lines and basic shapes. But it will be difficult to create complex patterns and shapes using the pen tool. For that we have to use the stamp tool. What this tool does is that, it stamps the image of the sprite onto the stage, just like actual rubber stamp seals are used in an office. It is possible to draw complex patterns by combining the stamp tool with other command blocks such as turn as well as repeat. Try the following scripts. In previous sessions, we learned how to animate the sprite. Now let's apply a few graphical effects on these animations. The looks palette contains the blocks to create graphic effects. The set effect block from the looks palette can be used to apply graphic effects onto sprite costumes as well as backdrops. The Clear Graphic Effects block clears all the effects applied. Suppose there are more than one sprite on stage. The order in which the sprites are drawn on screen can also be altered. This becomes necessary when sprites overlap. The Go to Front layer makes the sprite to be drawn on the topmost layer on the stage, whereas the Go to Back layer causes the sprite to be drawn on the bottommost layer on the stage. Similarly, blocks such as the Go Forward layers and Go Backward layers makes the sprite to be redrawn as many layers backward or forward as specified. Let's try an application. We shall apply this on the dance party project we did earlier. We do a story animation here. The story is as follows. The princess decides to take a walk outside the castle. Suddenly a lion appears out of the jungle. The princess calls the fairy for help. The fairy appears and makes the princess a dragon using the magic wand. The lion runs away. The fairy brings back the princess from the dragon avatar. The fairy disappears and the princess runs back to the castle. We will need 3 sprites. A princess sprite, a lion sprite, and a fairy sprite. The princess sprite needs a dragon costume also. The sprites may be drawn or selected from the library. Include appropriate backdrops as needed. The animation is shown here. The script can be downloaded. Try it out. Be more creative, and if you feel to include more events and characters into the story, you may do so. Let's solve a maze. We help a dog sprite find its way back to home. We have to move the dog sprite through the correct path to reach its home. To move the sprite, we could use the motion blocks. But when does the dog sprite move? Well, the dog sprite has to move when the arrow keys on the keyboard are pressed. If we press the up arrow key, the sprite has to move forward. If we press the down arrow key, the sprite has to move backward. If right arrow key is pressed, the sprite has to turn right. And if the left arrow key is pressed, the sprite has to turn left. The next question that comes to our mind is, how to detect the key press in Scratch? The key pressed block from the sensing palette can be used to detect if a certain key was pressed. You can select the key to be detected by clicking on the down arrow. So to sense a key press, this key pressed block can be put in a if-then block from the control palette and used appropriately. Try the script shown here. So we shall be using these conditional blocks to detect the key press, move the sprite, and thus solve the maze. Another requirement is that whenever key press is detected, a barking sound also has to be played. To do this, first we include a dog sprite with multiple costumes and a suitable backdrop. Whenever a key is pressed, the costume is changed and the sprite is moved or turned appropriately. Also, we will be tracing the path of the dog sprite using pen tool. The script is available for download. In this session, we solved the maze using keyboard. Let's solve the maze again. We help a dog sprite find its way back to home. We have to move the dog sprite through the correct path to reach its home. To move the sprite, we could use the motion blocks. But when does the dog sprite move? In the previous session, the dog sprite moved on pressing the arrow keys. But this time, the requirement is to move the sprite on moving the mouse pointer. The sprite has to follow the mouse pointer and trace the path using the pen tool. The next question that comes to our mind is, how to make the sprite follow the mouse pointer in Scratch? For that, first we have to make the sprite point towards the mouse pointer. Then, we have to move the sprite to the mouse pointer. The point towards mouse pointer block from the motion palette makes the sprite always point towards the mouse pointer. Whereas the go to mouse pointer block can move the sprite towards the mouse pointer. So to make the sprite follow the mouse pointer in Scratch, these two blocks can be put in a forever block. Try the scripts shown here. Another requirement is that, whenever the sprite touches the mouse pointer, the barking sound also has to be played. For that, the touching mouse pointer block from sensing can be used in a if block. Try the scripts shown here. So we shall be using these motion and sensing blocks to make the sprite follow the mouse pointer and solve the maze. We include a dog sprite with multiple costumes and a suitable backdrop. On dragging the mouse pointer through the required path, the sprite follows the pointer and traces the path followed. The script is available for download. We build a simple calculator that can do addition, subtraction, multiplication and division in this session. Any guesses on the blocks to be used for this purpose? We have to use the blocks from the operators palette for doing this. The arithmetic operators include addition, subtraction, multiplication and division. Let's try it. How do we store the results? Also, how do we store the operands and the operators of these arithmetic operations? For that, we have to use variables. Variables are nothing but containers that can store data or information. Now let's create variables and use them in these arithmetic operators. The operands are num1 and num2. Another type of operators are relational operators. Relational operators can be used to compare same type of data, such as to compare two numbers whether they are equal, or if one number is greater than or lesser than the other number. Let's move on to build the calculator. The calculator script should start running when the spacebar key is pressed. On pressing the alphabet key, C, the previous results will be cleared. The user is prompted to enter the numbers and the operation to be performed using the ask and wait block. Variables for storing the two input numbers, the operation, and the result is also created. Once the operation is completed, the result is displayed using say and join blocks. The script is available for download. We perform dice rolling in this session. We usually roll a dice when we play board games. Here we create that dice and roll it in Scratch. So first we create the dice sprite with 6 costumes. Each costume show one of its faces. On pressing the spacebar key, the dice script starts running and shows costume 1 as starting face. On pressing the alphabet key, R, the dice rolls and shows a random face. The randomness is obtained using the pick random block from operator's palette. The range of pick random is given from 1 to 6, indicating the faces. To indicate the rolling of the dice, along with face change, the dice sprite is turned, as well as its costumes are changed. Let's try it out. The script is available for download. In this session, we do a multiple choice question test using Scratch. There will be 2 questions in total. Each question will have 3 options. On clicking the right answer, the student gets 5 points. On clicking the wrong answer, the student gets -1 point. At the end of the test, the total marks is to be displayed. The script is available for download. In this session, we create a simple animation of a sprite walking in the rain. Suitable backdrops are created for simulating the rain effect. The backdrop is chosen randomly using the pick random operator. Try the script. The script is available for download also. In this session, we implement a table tennis game in Scratch. The supporting document can be downloaded. The script is also available for download. Watch the animation and try to implement it yourself. So that completes our first level in this course. We have an assessment next. See you there. Thank you.